This is for Year 12 Methods, and it is 1.1 question number 22. If c of x equals this expression, part A is show that c of x has repeated factors, and part B, find the value of k if c of x is a perfect cubic. Remember, a perfect cubic would look like x minus 1 cubed or x minus 3 cubed. It has the one factor, and that factor is raised to the power of 3. Okay, show that it's got repeated factors. I'd like to factorise. If I'm going to factorise this, then I need to use the factor theorem and find some factors. So p of 1 is going to equal 1 minus k minus 6 plus 6k plus 9 minus 9k. And even looking at the k's, I'm not going to lose the k's if I sub in 1 or if I sub in negative 1. So p of 2, and p of 2 is going to equal 8 minus 4k minus 24. 2 there is plus 12k plus 18 minus 9k minus 9, 3 minus 4. The k's don't disappear. P of 3 is going to equal 27 minus 9k minus 54 plus 18k plus 27 minus 9k. Minus 9k is 9k minus, the k's have disappeared. 27 and 27 is 54 minus 54 equals 0. So I found a factor. P of 3 equals 0. Therefore, I know that x minus 3 is our factor. I'm going to do a division and see if I can find some more factors. So in my division, I need to divide x minus 3 into, I've got x cubed. I have 2 bits of x squared, so I've got plus minus 6 minus k x squared. And I've got 2 bits of x that's plus 6k plus 9x minus 9k. Now to do my division, x goes into x cubed, x squared times. X squared times x is x cubed. X squared times minus 3 is minus 3x squared. I'm now going to subtract the second from the first. I have minus 6 plus 3 x squared, so that gives me 3 and minus k x squareds, plus 6k plus 9x minus 9k. X goes into this, plus 3 minus k x times. X, I've got negative 6 plus 3 is minus 3, which means that's minus 3. Minus 3 times x will give me minus 3 minus k times x squared. Minus 3x times minus 3 gives me plus 9. Minus k times minus 3 gives plus 3k x. Minusing the second from the first. This minus this is 0. I have 9 minus 9. I have 6k minus 3k gives 3kx minus 9k. X goes into 3kx plus 3k times plus 3k times. 3k times x gives 3kx. 3k times minus 3 gives minus 9k. And of course I get a remainder of 0. That's what I expected. So that gives me the factors, and the factors are x minus 3 and x squared plus minus 3 minus kx plus 3k. Is it possible to crisscross this? X and x are my two factors of x squared. 3 and k are my two factors of 3k. If I subtract them both, that still gives me positive 3k. X times that gives minus kx. X times that is minus 3x. Add them together, I get minus 3 minus kx, which is what I've got there. So that now gives me two more factors. And my factors are x minus 3, x minus 3, x minus k. And the question said, show that I have repeated factors. I have repeated factors of x minus 3 squared, x minus k, and there is my repeated factor of x minus 3. To do part B, it says find k so that it's a perfect cubic. Well, if it's a perfect cubic, it's got to be x minus 3 to the power of 3. Therefore, k has to equal 3. And if k equaled 3, that there would be x minus 3. So k equals 3 is the answer.